Alright guys, well I am back with another video on the this will be on the another Line 6 DL4. I just did a video on one of these, and I had mentioned in that one that a friend of mine gave me two of these to fix, and I repaired one of them, and that was what that previous video was on, and then I still had this one, which I believe I have fixed. Now I just potentially fixed this a few minutes ago, and I'm only saying potentially because the real test will be to plug it in to the guitar and amp. But yeah, this one was a little bit more, well, it wasn't as clear as to what was going on compared to the other one. With the other one, when I fired it up, all of the switches and LEDs were responding correctly. So it was clear that the microcontroller and the EEPROM chip were functioning correcly. So the problem with that one just happened to be an issue with the an op amp on the output. So this one was appeared to be in much worse shape as far as the symptoms it was giving. So initially, when I would apply power and plug in a 1/4-inch cable to the left input to turn it on, the only thing that would happen was the 4 LEDs would flash. And according to the manual, that means that the battery is low. Now, I wasn't powering it up with batteries. I was powering it with my DC power supply. I tried powering it with the AC adapter as well, and it was the same thing regardless. Wouldn't respond to any of the buttons, or any of the the knobs, nothing. And so it really kind of threw me for a loop. So I started looking at the EEPROM chip, thinking maybe there was something wrong there. I removed it and swapped it with this is actually my DL4. I swapped the chips, and mine worked perfectly fine with both of them. So I ruled that out as being a problem. And then of course, and you'll hear this on YouTube a lot as well, sometimes all that's needed is to get these back to life is reseating the EEPROM in the socket on the underside of the board. That wasn't the case either. So I started suspecting, maybe it was the microcontroller, which is right there, or something else on the digital side. But I was doing some comparison measurements with my oscilloscope, and from what I was getting, it just didn't. The microcontroller seemed like it was fine. It was still putting out the correct clock frequency, but I didn't rule it out completely. I started also suspecting maybe there's another chip right by the micro, and it's that little guy right there that says L46 on it. Now that is an interface for the EEPROM and the microcontroller. And so I thought, well, maybe there's something going wrong with that guy. Maybe it's not, there's an issue with it, so the microcontroller can't, there's some sort of interruption with the data being fed to the microcontroller. So I was just about to purchase one of those on Mauser, and then all of a sudden I started looking at the other sections of the board, and if you look over here, right by this analog to digital converter that says TLV 0838 on it, you can see all these diodes and resistors here. And you would think initially, just by looking at this board, that that has something to do with the expression pedal circuitry, and some of it does. But I started looking at these resistors, and one of them was slightly lifted up off the board, and it definitely almost didn't look like it was even soldered to the board. So I reflowed the solder to the resistors, and even the diodes looked a little bit in pretty bad shape too. So I just reflowed them all, and I was like, well, no, there's no way that can be it. And sure enough, I fired it up, and it started working. You know, so I don't have the switches, obviously. Let me see if I can. Yeah, see, there's a. Yeah, so now it's responding. The buttons are responding, and the LEDs are working. And I'm excited. I'm in the lab right now, but when I get home, I'm gonna plug this guy in and see if it works. But you know, I wanted to look into this a little bit closer as to what would cause this to have symptoms of just low battery. And so what's great about these, and I mentioned this before in the other video, is you can still find schematics for this online. And I have that pulled up now. So that one resistor that was clearly not soldered, it looked like it was lifted. Half of it was kind of sticking up. I can't believe I didn't see it earlier. That resistor's R52. So let's take a look at the schematic here. Now R52, you can see it right there, that 20K resistor, and you can see there's a V plus there, and then it goes to this TLV0838. That's an analog to digital converter. So it goes to channel, let's see, channel 6 on this analog to digital converter. And you can see there's other, you can look at what else is connected to this ADC. You've got this, the speed control knob, depth, shape, feedback, mix, all the pots connect to this ADC. The switches do as well. You know, so they're taking that analog signal and converting it to digital. And then, of course, you got the expression pedal too. So all of the other stuff sort of makes sense when you think about it, but then what is going on here? Where does this V plus come from? And it goes through a couple resistors and then goes to the ADC. What is that there for? And so, well, where does V plus come from? Well, let's see. You go up, this is V plus. That's where that's coming from, and it's coming right from the battery. But still, so what could that possibly be for? Well, you know, a lot of devices, you've got to, if they're battery powered, you've got to monitor the life of the battery. And so what likely this is being used for, this ADC is being used to determine the life of the battery. And so with that resistor being lifted up off the pad, it was thinking that the battery was low. And I mean, that makes perfect sense to me. I mean, if somebody else knows a little bit more about these things and wants to correct me, by all means. But that's what I think was going on here with this. And, you know, that's why when you're working on electronics, it's always good to do a good, thorough visual inspection of the board. You know, because normally, and I've been doing this for a while now, and I should have suspected it being something like this first. When you have these problems like this, which seem to have complex symptoms or leading towards something that's really complex, it's probably something really simple, like, you know, a cold solder joint, or you know, an SMD component that's not soldered all the way to the pad. You know, it's usually those types of issues, and it's really easy to start going down a rabbit hole with these. And especially, I mean, this is just a, you know, it's a complex guitar pedal, but I mean, when you're there are electronics out there that are much more complex than this, and it's very easy to start going down a rabbit hole and, you know, really leading yourself astray from what you really should be looking at. So, but I thought that was pretty cool. You know, that's what was going on, and well, I'm excited to take this home. If it does work, I'll put in a little video showing it working. If it doesn't work, well, I'll show you guys what's going on there. But all right. I should one thing reminded me of something. I initially did check the power supply section of the board before starting to check the EEPROM and the microcontroller. You know, that was one thing that maybe I didn't make clear at the beginning of the video, but as you can see, it's working great. Yeah, I hope you guys found that interesting. All right.